Next, what we're going to look at is reflection and dilation of function. All right? Hey, focus on me, please, everyone. Yesterday, I talked about the translation. Translation, listen, is actually the function does not change any shape at all. No reflection, no dilation. The function just moves left or right or up and down. All right? The shape remains the same. Dilation, the shape will change. All right? It will either be squashed in or expanded out. Reflection, it could have the change of shape and then reflect by the x-axis or y-axis. All right? So now we are only going to concentrate on these two, and then next week we're going to put everything together. If you don't need your laptop, close your laptop, please. So you need to think about the definition of dilating parallel to an axis, either the x or the y-axis. Then you're going to apply an understanding of the graphs of functions to generalize and describe the transformation of a times fx or b times fx. All right? Next week we'll combine everything. So we should be able to solve algebraic problems involving dilations and recognize the conditions of the reflection about the axis. So you could be reflecting about the y-axis or reflecting about the x-axis. All right? Two things that you need to know. So now, let's talk about the linear transformation of a quadratic function. So if I started off with the rate function, all right, we can see that what I've done is, if I transform the rate to the blue, from this point on, I've actually moved it up here by a certain factor. All right? Or the other way to look at this is moving from here out. All right? By a factor. Right? So what we're going to think about is, what do we do? Do we change the y coordinates by multiplying by a factor, or do we change the x-axis by multiplying by a factor? All right? Multiplying by factor. So there are two conditions that you've got to think about. All right? What we'll do is start thinking about if I go from fx to f of bx, or fx transform to a of x. Okay? Two different things. One affects the x coordinate, one affects the y coordinates. All right? Now, first thing let's look at is the horizontal dilation, which is b. Is dilation parallel to the x-axis? And the transformation fbx generalizes a dilation parallel to the x-axis with a factor of 1 over b, which, if you can think about it, is stretched horizontally. So if it is bx, the dilation is parallel to x-axis, a factor of 1 on b, 1 over b. So if it is fx to f of 2x, it affects the x coordinates, and it's 1 on, if it is fx to fbx, is 1 over b. All right? Multiply the x coordinate by 1 over b, which means it's stretched horizontally. In this case, that's the situation, stretching horizontally, not vertically. All right? Now, why is the horizontal dilation factor 1 over b? Now let's think about the concept of speed and time. If we go from fx to f of 2x, then the x-axis is speeding up by a factor of 2, where x represents the number of seconds. So for example, when we used to take 1 second to reach f1, it now will only take half a second, i.e. 2 times half to reach f1. All right? Think about it that way. So now, let's think about the horizontal reflection. The transformation fbx when b is less than 0 generalize a reflection about the y-axis, which means it's flipped horizontally. All right? So if you think about it, this, look at my iPad. What would happen is, if I've got something like this, I'm going to flip that way. All right? So from here, it's flipping negative to that way. Or from here, it's flipping from there to here, negative. So what it does is actually only affect the x coordinate. All right? B only affects the x coordinate. Think about it that way. B only affects the x coordinate. So this is the part of transformation that you need to know. So what would happen is, if I transform fx to f2x, let's say, for example, fx equals to x squared. So transforming it to 2x will be 2x all squared, which is 4x squared. All right? Think about the transformation. And then if I have transform it to minus f of 2x, that will be minus 2x all squared, which is 4x squared. All right. Now, let's think about the description of the transformation that would have occurred from fx to f of minus 3x. So there are two things that we are looking at. It's dilation. First, okay, hang on. Before that, let's think about this. When you're doing this situation, when you actually flip it over, all right, dilating, when you're reflecting about the y-axis, in fact, that really doesn't change at all. Because if you go from x squared, the axis of symmetry is y-axis, is x-axis, correct? Yeah? So whether it's 2x or minus 2x squared, it really doesn't matter. Whereas if you add in a translation, it will be different. All right? Bear in mind, this is the case. Those two are the same. All right? Yeah? Okay, good. So in this case, describe the transformation that would have occurred from fx to f of minus 3x. First, let's talk about the dilation. How much would it be dilated by? 1/3. Thank you. So dilation. All right. How would you describe it? I'm going to give you the way that I've stated it. So is dilation parallel to x-axis by a factor of 1/3. All right. Then the next bit is reflection. Is reflects about the y-axis. All right. Or you can say it's dilated parallel to x-axis by a factor of 3 and reflected about the y-axis. Yep.
Are we expected to do them in a order?
Yes, next week. There will be an order next week. All right? I will go through everything. There will always be an order next week. So when you do all the transformation, the order will be doing all the x's first, then all the y, which I will mention next week. Thank you. All right, the next one. What happened there? What have I done there? All right? What I've done is I have dilated the x by half. Correct? So, if it is by half, 1/2 is double, a factor of 2. So, it's dilated parallel to the x-axis by a factor of 2.
So if you draw the
If you want to sketch it out, yes, but sometimes this sort of question will not be in the calculator assume section because you are expected to know how to do the transformation. So it will most likely not be in the calculator whatever section, calculator assume section. Sorry? Beg your pardon? All right, if you want to do it, just grab your class pad out and do the plotting, if you like to. But I'm not really going to show you that because I would like all of you to learn how to think about using the function and doing the transformation. Because by the time it comes to the next bit, which is transformation of the trigonometric graph, it's going to be even more interesting. You've got to learn how this first. All right? So the next thing that you need to know is the vertical dilation. The vertical dilation is A. So this time is fx transformed to A times fx. All right? So let me write it down. Fx to A times fx. All right? The transformation A times fx generalizes a dilation parallel to the y-axis, factor of A, which means it's stretched vertically. If it is stretched vertically, it only affects the y-coordinates. All right? Not the x-coordinates, only the y-coordinates. So what you have learned is f of bx is horizontal dilation, A times fx is vertical. So next week, we should combine everything. I'm talking to a lot of my maths colleagues in and outside the school. We all really have to learn transformation very carefully again when we teach. All right? Just remember one thing. It's a concept that you need to know and you need to learn. All right? So, if you look at this, vertical reflection. The transformation A of fx when A is 0 is reflected about the x-axis. So this time, you're flipping vertically. If this is the x-axis, all right, you're flipping it down or up. All right, down or up. So think about you are changing the y. You're changing the y coordinate, not the x coordinate. Like I say, I'll put everything together next week. All right. Let's do some example. Describe the transformation that have occurred from fx to minus 5x. So it's dilated, parallel to the y-axis by a factor of 5 and then reflected about the x-axis. So what happened is it will be reflected, stretched vertically, and then flip over about the x-axis. Now, the next one is interesting. What you really need to think about when you've got a situation like this, you actually want to try to bring the transform back in the form of this 1 over x plus 2. So what would I do with this? So gx, let's take out the minus 3 so that it's back in the form of that. You will see that gx is now minus 3, 1 over x plus 2. All right? Always factorize. The method that I'm teaching you, the method of transformation I'm teaching you is always factorize. Factorize out so that this will look like that. You are using the minus 3 to multiply fx. Got it? So it's now from here. Fx, hey listen, fx is actually transformed to minus 3 times f of x. Correct? So what you want is make sure that you factorize everything out. It makes life a little bit easier if you do it that way. Especially when you start combining everything. Makes life a lot easier. So now fx is translated to, not translated, it's transformed to minus 3 of fx. So therefore, it's dilated parallel to the y-axis by a factor of 3 and then reflected about the x-axis. Alright? Now of course you can try it with your class pad or Desmos or GeoGebra online if you want to. But you've got to be able to learn without using graphics calculator. The next bit, example, before that, let's have a look at this. The L should be there, horizontal and vertical. So if I go from fx to f of bx, what you do is you multiply the x, alright, by, it goes from here to here. So if it is fx to f of 2fx is, if this point is p and q, this will be p divided by 2 and q. You do not change the y-axis, y-coordinates, but it affects the x-coordinate. Alright? So here, if it is minus, it's a reflection about the y-axis. This one, it affects the y-coordinate, not the x, and then it affects the y-coordinate by reflecting about the x-axis. Alright? Right, you can see my palm from here to here. Whereas this one is from here to here. Yeah? So remember, bx or minus bx affect the x coordinate, whereas this one affects the y coordinate. Alright. Next, some examples. So here, you are expected to be able to draw. So next week, you will have a whole series of exercises on how to transform one particular graph into many graphs by using a combination of all this. So if let's start looking at y equals f2x. Alright? So this time I'm going to use a blue line to do this. Alright? Blue line. What I would do is start thinking about all these points. These points. Now, let's have a look at the x coordinate of this. If this is 2. Now 2x, which means I have got to multiply it by 1/2, because this is affecting this is parallel to the x-axis. So we are moving it across to here. Right? 0. X is 0. Does it change? No, not at all. So you know you've got 2 points. Now you can look at this point as well. This will go from that to 1/2. Correct? And what I'll do is I'll look at this point. 4 points. And that will be from 1 to 1/2. So I've got 4 points. I can just sketch it out. Alright, so that is your y of x. This is f. Y equals f of 2x. Alright, the rate is y equals to f of x. Alright, the next one is reflection. Is this reflected about the y or the x-axis? This one would be y. So from here to here or here to there. Alright, again, look at those points. This one, it will go all the way to there. Alright? This reflected, it will go to here. this point will remain, and this point will come all the way to here. All right. So therefore, sketching it, if I can do it properly. I haven't done it really that well, but you get the idea. All right? You get the idea what happened to that. So that would be the black line. Now, what about the next one? Example 6. Example 6, again, use the same idea. Use this point, this point, this point, this one, and that. All right? So I've got this point. Those are the more defined point. And here. So this time, I am dilating it parallel to the y-axis. So I multiply everything by 2. So if I use the blue line again for the 2fx, this will go up to there. This will be, if it is minus 1, 2 times minus 1 is here. Here, this one will go up to there as well, correct? And finally, what about this y? It will go from minus 1 to minus 2. So it's this way. What am I doing? I need to change this color. All right. So that is approximately half here. That's approximately half there. It's just that I didn't draw it properly. All right. And then the blue, the black. The black. Once you've got this blue line, all right, you can actually think about it just reflecting the blue line, correct? Yeah? Because I've already dilated it, I just need to move it across, so that point will be there. This point will be there. And that will be the same point. This point will come across to here. So you will not have this. Like I say, I don't draw it very well with my iPad, but you get the idea.
So,
Yeah?
should that be this one? Like you should reflect it up.
Oh, hang on, did I? Oh yeah, sorry, my fault. Not thinking. Thank you. I'm not thinking. It's actually by the x-axis, not by the y-axis. Oops. Thank you. It's my fault. All right, you've got a blue line. Then you've got to reflect about the x-axis. So, yep, thank you. So that will go from here all the way down to 1, 2, 3, here. This will go all the way up to there. That will go up to here. And this will come all the way down to here. All right, so reflecting. All right, thank you. All right, this is how you do it. All right, I'm going to stop here. That's the end of the lesson. You should have some exercises to do from Google Classroom.